Students. Okay, good afternoon.
Good afternoon.
Good afternoon. All right. So in the previous class, we discussed about the addition of vectors and some numericals regarding with that of this vector addition. So that's all about the addition of vectors. And we have a small portion regarding with the subtraction of vectors. Right as heading, subtraction of vectors. Actually, subtraction of vectors are very simple as we are compared to that of the addition of vectors. Subtraction of vectors. Suppose we have two vectors, vector A with magnitude A. Suppose we have two vectors with vector A. We have two vectors, vector A with magnitude A and vector B with the magnitude B. Then the difference between these two vectors are given by vector A minus vector B is equal to A minus B. Okay, subtract the magnitude of a vector with a less magnitude from that of a vector with a large magnitude. So vector A minus vector B is equal to A minus B, or vector B minus, the reverse case is also possible. Vector B minus vector A is equal to B minus A. Try to subtract the vectors with a small magnitude from that of the vectors with a large magnitude. So vector A minus vector B is equal to A minus B. Similarly, vector B minus vector A is equal to B minus A. The reverse case is also possible. Or you just imagine, for example, one more case is here. For example, if we have vector A with the magnitude is equal to 10 meter. Vector B with the magnitude is equal to 8 meter. We have two vectors. Vector A with the magnitude 10 meter. Vector B with the magnitude 8 meter. Then the difference between these two vectors given by vector A minus vector B, that is equal to, we can add these vectors and take the negative of the second vector. That is magnitude of vector A plus negative magnitude of vector B. That is equal to 10 plus minus 8. That is equal to 10 minus 8 equal to 2. Or directly you can say 10 minus 8 is equal to 2 meter. This is the difference between two vectors. Okay. So vector A with the magnitude 10 meter, vector B with the magnitude 8 meter. Then the difference between these two vectors given by vector A minus vector B. That is magnitude of the first vector, the large vector A, plus negative magnitude of the second vector, minus of B. Minus of B, that is 10 plus minus 8, that is equal to 10 minus 8 equal to 2 meter. Or directly you can subtract these two vectors. 10 minus 8 is equal to 2 meter. Both are possible. And always try to keep in mind, must subtract the small vector with a small magnitude from that of the vector with a large magnitude. So that's all about the subtraction of vectors. It's a simple case. Normally we are try to practice the problems more regarding with that of the addition of vectors, not with that of the subtraction. Addition of vectors and multiplication of vectors are the very important topics of this chapter, motion in a plane. Because under the subtraction, addition of vectors, we are discussing more cases. If the vectors are aligned in the same direction, if the two vectors are in the opposite direction, if the vectors are inclined at an angle. So there are different cases are comes under the vector addition. So that's why vector addition topic is more important as compared to that of the subtraction of vectors. Is it clear? Subtraction of vectors. We just subtract the two vectors. That's all. Clear?
Yes, ma'am.
Okay. So now we are moved to the next topic. Multiplication of vectors. All of you write the next heading. Multiplication of vectors. Multiplication of vectors. Under this topic, multiplication of vectors, we have to discuss three subtopics. The first case, multiplication of a vector by scalar. Multiplication of a vector by scalar. Second one, scalar product. Scalar product or dot product. Scalar product or dot product. The last one, vector product or cross product. Vector product or cross product. So we are going to discuss these three topics one by one. Multiplication of vectors. Multiplication of a vector by scalar. Scalar product or dot product. Vector product or cross product. So first of all, we are going to discuss multiplication of a vector by scalar. Multiplication of a vector by scalar. Multiplication of vector by scalar. Let vector A means A with arrow mark. Vector A is multiplied by a scalar M, where M is a quantity. It is a scalar quantity. It possesses only magnitude, not direction. So here we are going to multiply the scalar quantity M with that of a vector quantity vector A. Then if M is a positive quantity, only magnitude of the vector will change by a factor M and its direction will remain the same. If M is a negative quantity, the direction of the vector will be reversed. These are the two characteristics. Multiplication of a vector by a scalar. You just, first of all, you write the statement. After that, we can explain it with the help of an example. Let vector A is multiplied by a scalar M. If the scalar quantity M is positive, only the magnitude of the vector will change by a factor M and its direction will remain the same. If M is a negative quantity, the direction of the vector will be reversed. And mathematically, the multiplication of a vector by scalar is represented by, here we have a scalar quantity M, multiplied it with a vector quantity, vector A. So M into vector A is equal to M times the magnitude of vector A into unit vector A cap. This is the mathematical representation for multiplication of a vector by scalar. M vector A is equal to M into magnitude of vector A into A cap, unit vector A cap. If m is a positive quantity, only magnitude of the vector will change by a factor m and its direction will remain the same. If m is a negative quantity, the direction of the vector will be reversed. Is it over? Okay. Write the definition for multiplication of vector by scalar and the two characteristics of the multiplication of vector by scalar. Here we have the mathematical representation for multiplication of vector by a scalar. Here m is represent the scalar quantity and vector a represents vector. So here a scalar quantity is multiplied with the vector. Then we get m times magnitude of vector a into unit vector a cap. Is it over? Adulya?
Yes, ma'am.
Okay. Write one example. Let vector A is equal to 5i cap plus 3j cap plus k cap, 2k cap. Then calculate 5 vector A. Let vector A is equal to 5i cap plus 3j cap plus 2k cap. Then calculate 5 vector A. Can you identify the scalar quantity here? Scalar.
5.
Yes, very good. Here 5 represents the scalar. So here we know that vector A is given as 5i cap plus 3j cap plus 2k cap, which implies 5 vector A. What is the equation for 5 vector A? Previous equation. 5 vector A means 5 into magnitude of vector A into A cap. So it becomes 5 into, here we have 5i cap plus 3j cap plus 2k cap. Here in that equation, magnitude is not present. No magnitude. You just rub that magnitude. 5a cap is equal to 5 into 5i cap plus 3j cap plus 2k cap. So it becomes multiply into the bracket. 5 into 5, 25 I cap plus 5 into 3, 18 J cap plus 5 into 2, 10 K cap. This is the answer. Try to connect it with the first characteristics of multiplication of a scalar by a vector. Multiplication of scalar by a vector.
Ma'am.
Yes.
15 J cap.
Yes.
15 J cap. And it's 15 J cap.
1 minute. It's not clear to me. Can you chat?
Ma'am, it's 15 J cap.
Ah, yes, yes. Right, right. Thank you, dear. 15 J cap. Sorry. 5 into 3, 15. Yeah. So, according to our second characteristics, if M is a positive quantity, only the magnitude of the vector will change by a factor m and its direction will remain the same. So there is no change in the direction here. Only the magnitude is changes, no change in the direction. Magnitude is changed by a factor of 25 I cap plus 15 j cap plus 10 k cap. There is no change in the direction. Now suppose we can consider another case. Let vector A is equal to 6j cap plus 6i cap plus 2j cap minus 3k cap. Let vector A is equal to 6i cap plus 2j cap minus 3k cap. Then find minus 3 vector A, negative 3 vector A. So here we have vector A is equal to 6i cap plus 2j cap minus 3k cap, which implies minus 3. Negative vector A is equal to negative 3 into vector A, that is 6i cap plus 2j cap minus 3k cap. Negative 3 into 6, negative 18 I cap. So here the direction changes because here we multiply the vector with a negative scalar quantity. So it becomes negative 18 I cap minus 3 into 6, minus 6 j cap minus 3 into 3 plus 9 k cap. So if you are multiplying a vector with a negative scalar quantity, its magnitude and also the direction is changes. But in the previous case, we are multiplying the vector with a positive scalar quantity. Its magnitude is only changes by m times, but the direction remains the same. Here in this present case, both the direction and magnitude is changes. It will depends upon the sign of the scalar quantity that we are used here for multiplication. So that's all about the multiplication of a vector by a scalar. Okay, multiplication of a vector by a scalar. Suppose if you are asked to find out the multiplication of a or the product of lambda into vector A. What about the product of lambda into vector A? Here lambda is a scalar quantity. And this is a vector quantity. Find the product of lambda into vector A. What will be the answer? Lambda vector A. Try to correlate it with that of the general equation for multiplication by a scalar by a vector, multiplication of a vector by a scalar quantity, lambda vector A. What will be the answer? Lambda vector A is equal to dash. Lambda vector A.
Lambda into magnitude of vector A into vector A.
Very good. Lambda into magnitude of vector A into A cap. Very good. This will be the answer. Similarly, you can form equation for any scalar quantity. If you are asked to find out the 3 vector A, 3 vector A is equal to dash. The answer will be 3 vector A is equal to 3 into magnitude of vector A into A cap. Whether the vector A is given, you just substitute instead of vector A, you just substitute that value. Okay. So this is what is about the multiplication of a scalar by vector. Now we are going to discuss the next topic. Multiplication of a vector by vector. Okay. So multiplication of a vector quantity, under this topic, we have two subdivision. Multiplication of a vector by scalar. Multiplication of a vector by vector. Multiplication of vector by vector, we have to perform two methods. One is dot product or scalar product. And the second one is cross product or vector product. So the first method is over. That is the multiplication of a scalar by vector is over. Now we are going to discuss multiplication of a vector by vector. We are going to multiply two vectors. So under this topic, we have to discuss two subtopics: dot product or scalar product, cross product or vector product. So first of all, we can discuss about dot product or scalar product. Dot product or scalar product. Write the definition for dot product or scalar product. The dot product of two vectors, vector A and vector B, is defined as the product of their magnitudes and the cosine of the smaller angle between the two vectors, vector A and vector B. The dot product of two vectors, vector A and vector B, is defined as the product of their magnitudes and the cosine of the angle between the two. I think it is better to take the capital A and capital B. The dot product of two vectors, vector A and vector B, is defined as the product of their magnitude and the cosine of the smaller angle between the two. This is the actual definition for the scalar product or dot product. And the result of this vector A dot vector B is a scalar quantity. The product or the result that we are obtained after this multiplication is a scalar quantity. That is why we call it as scalar product. So here we are going to represent this vector scalar product or dot product mathematically. So we have two vectors, vector A and vector B. This product is known as dot product. So here vector A dot vector B. Vector A dot vector B is equal to the dot product of two vectors, vector A and vector B, is defined as the product of their magnitude. Product of their magnitude means modulus of vector A, modulus of vector B, and the cosine of the small angle between them, cos theta. Vector A dot vector B is equal to product of the magnitude of vector A and B and the small angle and the small cosine angle between them. Or we can write vector A dot vector B is equal to, what is the magnitude of vector A? Magnitude of vector A. Magnitude of a vector is A. Magnitude of vector B. B. Okay. So vector A dot vector B is equal to AB cos theta. This is the mathematical expression for dot product or scalar product. We have two vectors, vector A and vector B. Now we are consider the dot product of these vectors. That's why here we are putting a dot. Vector A dot vector B. Vector A dot vector B is the product of the magnitude of these two vectors. That is vector A into magnitude of vector B and the cosine of the small angle between them. That is taken as cos theta. So vector A dot vector B is equal to magnitude of vector A is A, magnitude of vector B is B. So it is vector A dot vector B is equal to AB cos theta. And the result of this dot product is a scalar quantity. The result of this dot product is a scalar quantity. That is why we call it as a scalar product. The dot product is also known as scalar product because the resultant or the product that we are obtained after this multiplication process is a scalar quantity. Vector A dot vector B is equal to AB cos theta. This AB cos theta is a scalar quantity. It doesn't possess any direction. It only possesses the magnitude. That is why we call this dot product as a scalar product. Is it over?
Yes, ma'am.
Okay, so here we are discussing dot product or scalar product. Only need to write the equation. This is the mathematical representation for dot product or scalar product. That is vector A dot vector B is equal to AB cos theta. Dot product is always the relation between the magnitude of the vectors and that of the cosine of the angle between them. Okay. So vector A dot vector B is equal to AB cos theta. This is very, very important equation. You need this for your higher classes also. What about the dot product or scalar product? Vector A dot vector B is equal to AB cos theta. Now write the next subheading, characteristics of dot product or scalar product. Characteristics of dot product or scalar product. The first characteristics, it depends on the angle between them. It depends on the angle between them. It depends on the angle between them. That is, suppose if theta is equal to 0 degree. If theta is equal to 0 degree. What is the general equation for dot product? Mathematical expression for calculating dot product.
AB cos theta.
Magnitude.
Yes, vector A dot vector B is equal to AB cos theta. This is the general expression for calculating the dot product or scalar product. Now, suppose if theta is equal to 0 degree. If theta is equal to 0 degree, then vector A dot vector B is equal to AB cos 0. What is the value of cos 0? Cos 0 is equal to
1.
1. Here cos 0 is equal to 1. Therefore, we can write vector A dot vector B is equal to AB. So the value of dot product becomes AB. So we can say the dot product or scalar product is depends on the angle between them. If the angle between the two vectors, vector A and vector B is equal to 0 degree, then the value become AB. Vector A dot vector B is equal to AB. Simply the product of the magnitude of the two vectors. Now, if theta bit is the angle theta between these two vectors is equal to 90 degree. If theta is equal to 90 degree. Then what about vector A dot vector B? Vector A dot vector B is equal to AB cos 90. What is the value of cos 90? Cos 90. 0. Cos 90 is equal to 0. Then vector A dot vector B is equal to AB. Sorry, AB into 0, it becomes 0. Vector A dot vector B, if theta is equal to 90 degree, then vector A dot vector B is equal to AB cos 90. Since cos 90 is equal to 0, vector A dot vector B is equal to 0. Now one more angle. If the angle theta between these two vectors is equal to 180 degree, if theta is equal to 180 degree, what is the value of vector A dot vector B? Renil, vector A dot vector B becomes AB cos 180. 180 degree. What is the value of cos 180? Align cos 180. Sanjana, cos 180 degree.
-1.
Yeah, it is -1. Cos 180 is equal to -1. Okay. Cos 0 is equal to 1. Cos 90 is equal to 0. Cos 180 is equal to -1. Then the dot product becomes vector A dot vector B is equal to negative AB. So depending upon the value of angle between them, depending upon the value of angle theta, the product will be varies. Vector A dot vector B is equal to positive AB if theta is equal to 0. And if the theta is equal to 90 degree, vector A dot vector B is equal to 0. If theta is equal to 180 degree, vector A dot vector B is equal to negative AB. So this is the first characteristic. Dot product or scalar product depends on the angle between them. Now the second characteristics of dot product or scalar product, they obey commutative law. Obeys commutative law. This dot product or scalar product obeys commutative law. That is, vector A dot vector B is equal to vector B dot vector A. Both are commutative. Vector A dot vector B is equal to vector B dot vector A. Now, the third characteristics, dot product of a vector, dot product of a vector itself is the square of the magnitude of that vector. Dot product of a vector itself is the square of the magnitude of the same vector. Dot product of a vector itself is the square of the magnitude of the vector. Dot product of a vector itself is the square of the magnitude of the vector. That is, instead of vector B, you just consider we have the vector A itself. That is vector A dot vector A. Vector A dot vector A. Square of the magnitude of the same vector means we know that magnitude of vector A is A. Again, magnitude of vector A is A cos theta. So it becomes A square cos theta. Dot product of a vector itself is the square of the magnitude of the same vector. If we have, instead of vector B, we have the same vector A, that is vector A dot vector A into A cos theta, that is equal to A square cos theta.
Ma'am,
Yes,
will you explain that obey the commutative law?
obey the commutative law. Okay. Suppose you consider we have vector A and vector B with the magnitude. Suppose this is 3, this is 2. So we can write 3 into 2 is equal to 2 into 3. 3 into 2 means 6. 2 into 3, 6. Reverse process is possible. Just the basic mathematics. Vector A dot vector B. If we have two vectors, vector A with the magnitude 3 meter, vector B with the magnitude 2 meter. Okay. So we can write vector A dot B means 3 dot 2 is equal to 2 dot 3. This is commutative, exactly similar to that of the multiplication of numbers. And the third characteristics of dot product or the scalar product is the dot product of a vector itself is the square of the magnitude of the same vector. Instead of vector A, you can take it as vector B, no problem, but the second vector always remains same. Vector B dot vector B, which is equal to B square cos theta. B square cos theta. Now the next characteristics. If you have the unit vectors, what are the unit vectors along the x, y, and z directions? If you have the unit vectors, vector I cap, vector j cap, and vector k cap along x, y, and z directions, along x, y, and z directions, then I dot I cap dot I cap is equal to j cap dot j cap is equal to z cap dot z cap. Sorry, k dot k cap dot k cap is equal to 1. If we have unit vectors, the three unit vectors, vector I, I cap, j cap, and k cap. They are directed along the x direction, y direction, and z direction respectively. Then we can write I dot I is equal to j dot j is equal to k dot k. That is I dot I is equal to 1, j dot j is equal to 1. Similarly, k dot k is equal to 1. This will be more clear whenever we are doing some problems. You just try to recollect these equations. I dot I is equal to j dot j is equal to k dot k is equal to 1. That is, if you are consider or if you are take the dot product of any two unit vectors. Any two unit vectors means the same unit vectors I and I. The product will be equal to 1. But I dot j is equal to 0. I dot j is equal to 0. Similarly, j dot k is equal to 0. And I dot k is also equal to 0. The dot product of the same unit vectors are equal to 1. But the dot product of different unit vectors are equal to 0. Vector I dot unit vector I cap dot j cap is equal to 0. J cap dot k cap is equal to 0. I cap dot k cap is also equal to 0. The dot product of the different unit vectors are equal to 0. The last characteristics of dot product or scalar product, it obeys distributive law. It obeys distributive law. Distributive law in basic mathematics. Distributive law. It obeys distributive law. That is, vector A dot any other two vectors, sum of the two vectors, vector B plus vector D, that is equal to A dot B plus A dot D. Same as that of the mathematics. Vector A dot vector B plus vector D is equal to A dot B plus A dot D. That is, if you are consider vector A with a magnitude 10, vector B with a 3 plus 2, that is equal to 10.3 plus 10.2. Dot means here we are indicating this multiplication, 10 into 3 plus 10 into 2. Okay, so that's the time.